Okay, for today, we're going to go ahead and learn how we would go ahead and answer this type of question. How many molecules of copper carbonate in 125 grams of copper carbonate? So we're going to find molecules and we're given grams. So based on the chart that we saw the other day, we're actually going to go ahead and go from grams. Oops, let me go ahead and get something to write with here. From grams to moles, then from moles to molecules. Okay, and the way I'm going to do this is some of you guys might, see the first half, the first conversion, go, okay, I get it. I know how to do the other half. So I'm going to do that first. Before I do that, I want to go ahead and compare. So we did in the last worksheet. The last worksheet, we had moles of elements. These are moles of compounds. So here we have a compound. And that's what we're dealing with in this worksheet. Before we do that, let me go ahead and remind you how we did it on the last worksheet. And I want to show you kind of the difference. So this one just asks how many moles of copper. So it's the first conversion there. How many moles of copper in 75 grams of copper? Right. So you're given, see, 75.0 grams of copper, and you want to convert it to moles. That's not where I'm going to stop. We could also, once we have moles, convert it to atoms because this is an element here. And remember, in order to turn grams to moles, so we're going here from grams to moles, we need the atomic mass. So if we look for copper, copper's right here. Its atomic mass is 63.55. So that tells us that 1 mole of copper has 63.55 grams. Notice how I put it on the bottom so that the grams of copper will cancel. And remember, the atomic mass tells us how many grams are in 1 mole of copper. All right, so I made my conversion factor. Basically, it's telling me 1 mole of copper is equal to 63.55 grams. So now my grams of copper are going to cancel. And when I do this calculation, it'll leave me with moles. Looks like a little over 1. Let's see. So if I take 75, I don't have my camera on today because I just got out of the shower and my hair's all goofy. So decided just to do this without the camera. 75 divided by 63.55 is going to be equal to 1.18. 1.18. Yeah, so 1.18 moles of copper. Okay, and there is your answer. Okay. If we want to find out how many atoms, then we'd go ahead and multiply by Avogadro's number, and we'd move on. But I just wanted to go ahead and put it there so we can compare how we're doing this, how we did it the problem of the last worksheet, and how we're going to do it this one. So there's a parallel between the two, in that we're starting with grams and turning it to moles. Here, same thing, grams turning into moles. The big difference here is that, let me go ahead and move this up, see if I can do this without getting rid of that. The big difference is that this is a compound. So I'm going to write down my given again. So here in this one, let me change it to this. Got 125.0 grams. Okay, copper carbonate. Have a hard time with my U's not looking like A's. I notice. I'm going to go ahead and convert it. Okay, but my conversion factor, last time my conversion factor I just looked up on the periodic table. You'll recall that yesterday's worksheet, we went ahead and calculated the molecular mass of copper carbonate. Right, and copper carbonate is made up of 1 copper and 1 carbon and 3 oxygens. Okay, so I can actually calculate this out looking up the atomic mass. We already know the atomic mass of copper. We can also look up the atomic mass of carbon right here, 12.01. Remember that? And oxygen, 16.0. Remember that? So that we can go ahead and say, all right, we've got 1 copper, 63.55, plus carbon, 12.01, plus oxygen, 16.00. right? Add those together. Let me see what I get. So once again, I'm doing my calculator here, 63.55 plus 12.01 plus, 3 times 16, because there's 3 oxygens. I almost messed that one up. Okay. So let me go ahead and fix that. So I'm going to have to multiply that by 3 times 3. Right? Because there's 3 oxygens. 3 oxygens. So that gives me a total of 123.56. 123. Oh, I didn't mean to make it that close to a mole, but apparently it is. All right. So 123.56 is the molecular mass of copper carbonate. That's adding the mass of the copper, the carbon, and 3 oxygens. Okay. So once again, just like I did up above, 123.56 grams of copper carbonate per mole of copper carbonate. Okay. And when I take 125 that it was given, divided by 123.56, what I get is 1.01 moles of copper carbonate. Okay, so I wanted to do this right here so you can see the difference. The difference was in both cases we're given grams. We're given grams in both cases. In order to turn grams of copper into moles of copper, I had to divide by the atomic mass, which I got directly from the periodic table. On this other one over here, marking this up, on this other one right here, I'm given grams of copper carbonate to turn it into moles. I had to divide by the molecular mass. So the big difference here was, let me go ahead and change color here. The big difference was that I had to calculate the molecular mass like we did on yesterday's worksheet. Okay. And remember, I had to multiply this one by 3 because there were 3 oxygens. Really, this formula has 1 copper, 1 carbon, and 3 oxygens. So how much would 1 copper, 1 carbon, and 3 oxygens weigh? Total, they would weigh 123.56. That tells me that 1 mole of copper carbonate is equal to 123.56 grams copper carbonate. All right. So once again, I made my conversion factor here by taking one side of it, putting it on top, the other side of it, this equality, putting it on the bottom, and I was able to, that would allow me to cancel out the grams of copper carbonate. Okay. And that got me 1 mole. So when I chose 125 grams of copper carbonate, I had to figure this out, so I didn't think it would be this close to a mole, but it is. I don't know if it's the best example, but it is what it is. All right, so I just want to kind of show you that. Some of you might go, oh, once I have molds now, I can turn it into molecules. So some of you guys might be done with this video. The rest of you, I'll go ahead and finish it because the question did ask for how many molecules. Don't confuse molecules with moles, but right now we have molds. We don't have molecules. We still need to turn moles into molecules. For those of you who are done, yay. For the rest of you want to continue watching to finish this problem, we will. I will go ahead and finish it here. So let's see. Let me go ahead and get my black pen again. And I'm going to bring down the 1.01 moles of copper carbonate. And I want to convert that into molecules. Remember that a mole is an Avogadro's number worth of anything. So I don't care if we're talking about atoms or molecules. It's still 1 mole. I'm going to put 1 mole on the bottom so that the units cancel. Is 6.02 times 10 to the times 10 to the 23rd molecules. Last worksheet, we were doing this with atoms. Molecules. Still having a hard time writing with this tablet. But believe me, it's not that much better than my regular Not that much worse than my regular penmanship anyway. So the moles are going to cancel out, leaving me with 1.01 times 6.02, 10 to the 23rd, and that is 6.09. Yeah, which is that much there. 6.09. 6.09 times 10 to the 23rd molecules. Sometimes I'll just put it as molic of copper carbonate. Okay, there is the answer. There's the answer to the whole problem. 6.09 times 10 to the 23rd molecules of copper carbonate. That's a C. Okay. Um, so we turned our grams to moles. And then once we had the moles, we went ahead and took that answer and converted our moles of copper carbonate into molecules. Notice the abbreviation for molecules is MOLEC. Because I think I've mentioned it before. M is, well, meters normally by itself. MO is month. MOL is the shortcut for moles, and MOLE is mole all put together. So in order to get a shortcut for molecules, uh, you have to put molec. I don't know if that helps all that much, to shorten it at least. Okay, so that's the big difference here in this worksheet. You're going to turn your grams into moles, but you need to your conversion factor, what you use to divide here or multiply if you want to turn moles to grams, is the molecular mass. And so you have to calculate the molecular masses, not just looking it up on the periodic table, but taking all the elements that are in your formula and getting their atomic masses and adding them up. That's why we did the worksheet on molecular mass uh, previously, so that we can go ahead and calculate them out. Uh, Um, we know how to calculate the molecular mass. Okay, so that's it with for this one.